Can deuterium change the future of semiconductor manufacturing? In this video, we dive into the incredible role of deuterium in advanced chip production and semiconductor innovation. Discover how this powerful hydrogen isotope is helping companies like Intel and TSMC push the limits of chip performance and microchip technology. Is deuterium the secret ingredient to the next-gen microprocessors? Let's find out. In the world of advanced technology, the materials used in semiconductor manufacturing are crucial to the success of the devices that power everything from smartphones to supercomputers. One such material that has gained increasing attention is deuterium. Although not a new element, its applications in the semiconductor industry are still being explored. Today, we'll take an in-depth look at deuterium's role in semiconductor manufacturing, its origins, and the companies and researchers driving its use in the industry. Deuterium, also known as hydrogen-2, is a stable isotope of hydrogen. It differs from the most common isotope of hydrogen, protium, by having one proton and one neutron in its nucleus, twice the mass of regular hydrogen. Deuterium is naturally occurring, but in much smaller quantities compared to regular hydrogen. It makes up about 0.015% of all hydrogen found on Earth. But why does it matter to semiconductor manufacturing? In semiconductor fabrication, the precision required in processes like lithography, etching, and chemical vapor deposition is immense. Any variation in these processes can lead to defects in the final product. The high purity and isotopic precision required for semiconductor materials is why deuterium has become an intriguing option in recent years. The concept of using deuterium in semiconductor manufacturing isn't brand new, but it has recently gained traction as industries push the boundaries of miniaturization. Researchers first discovered the potential benefits of deuterium in semiconductor production in the early 2000s, as materials science began to evolve alongside the growing demands of next-gen technology. The use of deuterium in these processes helps minimize isotopic contamination, ensuring a higher level of consistency and efficiency in semiconductor production. By replacing regular hydrogen with deuterium, manufacturers can control certain chemical reactions more precisely, leading to better quality semiconductors. Now let's delve into the fascinating world of companies that are currently utilizing deuterium in their advanced manufacturing processes. Deuterium, a stable isotope of hydrogen, is gaining traction for its unique properties that can significantly enhance semiconductor performance. While the adoption of deuterium in semiconductor manufacturing is still in its early stages, a few pioneering wafer companies are already experimenting with it. These companies are at the forefront of innovation, pushing the boundaries of what's possible in semiconductor technology. One such company is Intel, a name synonymous with cutting-edge technology and innovation. Known for its innovative approach to semiconductor production, Intel has been actively exploring the potential of deuterium in its chemical vapor deposition, or CVD processes. This exploration is part of Intel's broader strategy to maintain its leadership in the semiconductor industry. The application of deuterium in CVD processes can significantly improve the uniformity of thin films, which are essential for creating highly integrated circuits. These thin films are crucial for the performance and reliability of modern electronic devices. Similarly, TSMC, or Taiwan Semiconductor Manufacturing Company, a global leader in semiconductor manufacturing, has begun pilot programs incorporating deuterium into its process flows. TSMC's initiatives are part of its commitment to staying ahead in the highly competitive semiconductor market. TSMC's focus has been on leveraging deuterium to improve the precision of critical etching processes and to enhance the overall material quality of semiconductor wafers. By doing so, TSMC aims to produce more reliable and efficient semiconductor components, which are vital for the next generation of electronic devices. Both Intel and TSMC are setting the stage for a new era in semiconductor manufacturing. Their efforts in utilizing deuterium not only highlight the potential of this isotope, but also pave the way for future advancements in the industry. As these companies continue to innovate, we can expect to see even more exciting developments in the world of semiconductors. The journey of integrating deuterium into semiconductor manufacturing is just beginning, and the possibilities are endless. With leading companies like Intel and TSMC at the helm, the future of semiconductor technology looks brighter than ever. Deuterium is also being explored in the field of advanced lithography. Lithography is the process that defines the intricate patterns on semiconductor wafers. As the demand for smaller and more powerful devices grows, the need for more precise and reliable lithography techniques becomes paramount. Deuterium, due to its slightly heavier atomic mass, can have a significant impact on how light interacts with materials during the lithographic process. Researchers have shown that incorporating deuterium into photoresist materials, substances that respond to light during exposure, can improve the resolution of patterns and reduce unwanted side effects like distortion. Another critical aspect of semiconductor manufacturing is the process of doping, which is used to modify the electrical properties of semiconductor materials. Doping involves introducing impurities into the semiconductor to change its conductivity. Deuterium plays a unique role here as well. Unlike regular hydrogen, deuterium has an extra neutron, making it heavier and more stable. By incorporating deuterium during doping, scientists have observed that the dopants remain more stable in the material, reducing the likelihood of unwanted reactions. This stability leads to more consistent electrical properties, which is crucial for the performance of semiconductor devices. In the race to develop chips that are faster, smaller, and more energy efficient, every detail matters. Even the smallest improvement in material stability can make a huge difference in the final product. This is where deuterium shows its true value, its ability to fine-tune the atomic structure of semiconductor materials at a level that traditional hydrogen cannot match. This fine-tuning can lead to significant advancements in chip performance and longevity. As the demand for more powerful and efficient electronic devices continues to grow, the role of deuterium in doping processes becomes increasingly important. Its unique properties offer a competitive edge in the ever-evolving field of semiconductor technology. So, what's next for deuterium in semiconductor manufacturing? The future looks incredibly promising as researchers and engineers continue to explore its potential benefits. Deuterium, a stable isotope of hydrogen, has unique properties that can significantly enhance the performance and longevity of semiconductor devices. Although it's still a niche application, the ongoing research and testing of deuterium's role in advanced semiconductor production show great promise. Scientists are particularly interested in how deuterium can improve the thermal stability and electrical characteristics of semiconductor materials, which are crucial for the next generation of electronic devices. We can expect more major semiconductor manufacturers to adopt deuterium-enhanced processes in the coming years, particularly as they continue to push the boundaries of device miniaturization. The ability to create smaller, more efficient, and more powerful devices is a key driver in the industry, and deuterium could play a pivotal role in this evolution. Some other companies to watch in this space include Samsung Electronics, who is also investigating deuterium's role in wafer production. Samsung is at the forefront of semiconductor innovation and is exploring how deuterium can be integrated into their existing processes to enhance performance and reliability. They are particularly focused on how deuterium can improve the precision of their deposition techniques, which is a critical aspect of semiconductor fabrication. By incorporating deuterium, they aim to achieve higher levels of accuracy and efficiency in their production lines. The precision of deposition techniques is essential for creating high-quality semiconductor devices. Deuterium's unique properties can help in achieving this precision, leading to better performance and longer-lasting devices. As more companies explore this potential, we may soon see deuterium become a standard part of the semiconductor fabrication toolkit. The collaboration between industry leaders and research institutions will be crucial in unlocking the full potential of deuterium in semiconductor manufacturing, paving the way for the next wave of technological advancements. As we continue to rely on semiconductors for virtually every aspect of modern life, innovations in manufacturing processes will be key to meeting the growing demand for smaller, faster, and more efficient devices. Deuterium, with its potential to enhance precision, stability, and performance, is undoubtedly an exciting frontier in the world of semiconductor manufacturing. In CVD, deuterium is used as a part of the precursor gases in the deposition of thin films on semiconductor wafers. Because of deuterium's heavier atomic mass compared to hydrogen, it helps to control the movement of the molecules during the deposition process. From academic research groups to leading industry giants, everyone is keeping a close eye on how this isotope could shape the future of technology. The next few years will be crucial in determining how deuterium will be integrated into mainstream semiconductor production. The use of deuterium is still relatively niche and experimental in semiconductor fabrication. Research is ongoing to understand how to incorporate it more widely into production processes. The impact of deuterium on semiconductor performance, especially in future generations of microprocessors and system-on-chips, could be significant as the industry pushes towards smaller, more powerful devices. Stay updated with the latest in cutting-edge semiconductor technologies application on deuterium. Thanks for watching. Subscribe for more insights on technology and innovation. Remember this important message from the beginning, Proverbs 2:6, NIV. For the Lord gives wisdom, from his mouth come knowledge and understanding.